Hello there, and welcome to a quiet journey into the very fabric of reality. I am so glad you found your way here, to this space where curiosity meets calm, and the wonders of the universe gently guide you towards rest. Tonight, we're embarking on an exploration not of distant stars or ancient worlds, but of the incredibly small, the impossibly fundamental, the realm where all things begin to whisper their true nature. You've got nothing to do but settle in. Let your mind relax, your breathing slow, and your body grow light, as if gravity itself has softened its hold. We'll be uncovering some of the most profound truths the cosmos has to offer, not to challenge your thoughts, but to gently reshape them, allowing you to drift into a deeper sense of peace. If these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, and perhaps discover their own path to gentle rest through the quiet marvels of science. For tonight, we invite you to release all preconceived notions of the world, all the familiar frameworks we use to understand what is. Because the realm we are about to enter is one where even the concept of existence takes on a different meaning. This is the starting point of everything, the quantum realm, a place where reality dances to a different, more mysterious tune, and where your very perception of what is true will be tenderly rewoven. The world we see, touch, and experience every single day feels so wonderfully smooth and continuous. Think of the flow of water, the gentle sweep of a brushstroke on canvas, or the seamless passage of time from one moment to the next. Our senses, honed by eons of evolution in a macroscopic world, tell us that reality is an unbroken, infinitely divisible continuum. We perceive a continuous spectrum of light, a continuous range of sounds, a continuous journey through space. Yet, the first astonishing truth whispered by quantum physics is that, at the very deepest, most fundamental scales, everything, absolutely everything, is discontinuous. It exists in discrete packets, in tiny, indivisible units, much like individual beads on a string, or perhaps like the minuscule, vibrant dots that compose an impossibly high-definition image. This isn't just about atoms, which we've grown accustomed to imagining as tiny building blocks. No, it delves far deeper than that. Energy itself, which fuels every process in the universe, isn't a continuous flow that can be endlessly subdivided. Instead, it comes in specific, quantized amounts, discrete bundles known as quanta. Imagine sunlight streaming through your window. It feels like an endless golden river, a continuous wash of warmth and brightness. But at its core, that light isn't a river. It is a cascade of individual, unchangeable packets of energy, called photons. Each photon carries a specific minimum amount of energy, and you can't have half a photon, or a quarter. It is either there, a whole indivisible unit, or it is not. This granular nature extends beyond energy. Even space, the very expanse in which we exist, and time, the steady march of moments, are theorized to be pixelated at unimaginably small scales. There might be a smallest possible unit of length, a cosmic pixel beyond which nothing else can be divided, known as the Planck length. And similarly, time itself might not be a smooth, ceaseless river, but rather a sequence of incredibly tiny, discrete nows separated by the Planck time, the shortest possible measurable duration. It's as if the universe isn't painted on an infinitely smooth canvas, but rather meticulously woven from countless intricate quantum threads. Or perhaps it's a living tapestry, constantly being knitted together from these smallest elemental stitches. This realization transforms our understanding of reality from a fluid, boundless ocean into something more akin to a vast, shimmering mosaic. Every breath you take, every thought that crosses your mind, every beat of your heart is an intricate dance of these discrete quanta. The solidity of the ground beneath you, the warmth of the air around you, the light that illuminates your dream sidle are composed of these fundamental indivisible units. It means that the universe, in its deepest essence, is not a blurring of infinitesimals, but a precise, elegant arrangement of definite, tiny bits. There's a quiet beauty in this revelation, a sense of underlying order and structure that might surprisingly bring a new kind of calm. To know that the grand sweeping narrative of the cosmos is built upon such precise, irreducible elements offers a sense of stability, a comforting thought as you gently drift. It is like discovering that a vast, flowing melody is actually composed of individual, perfectly tuned notes, each one essential, each one a complete entity. You are resting within this exquisitely pixelated reality, a gentle warmth in a universe composed of delicate, defined whispers of existence. We navigate our everyday lives by placing things firmly into distinct categories. A ball is a particle, a distinct object with a clear boundary, a definite location. A ripple spreading across a pond, on the other hand, is a wave-tunnel disturbance that spreads out, occupying many places at once without a sharp edge. These seem like entirely separate ways of being, distinct properties that never intermingle. Yet, the second profound truth of the quantum realm is that at the fundamental level, everything is delightfully, mysteriously, two-sided. Every single basic constituent of the universe, from the fleeting photon that carries light to the essential electron that gives structure to atoms, possesses both identities simultaneously. It is not one or the other, it is both always, an intricate dance of duality that defies our classical intuitions. Imagine trying to describe a whisper that is also a touch, or a color that simultaneously possesses a scent. It is challenging for our minds, accustomed to clear definitions. A photon, for instance, the quantum packet of light, can behave like a tiny focused bullet, striking a single point on a screen with precision. Yet that very same photon, when given the opportunity, can spread out like a wave, passing through multiple slits and a barrier at the same time, interfering with itself, much like ripples in water create complex patterns. It's as if a single tiny dancer can occupy every corner of the stage at once, or a single song can be heard in multiple dimensions simultaneously. And this isn't just a quirk of light. The electrons that swirl around the nucleus of every atom, forming the very matter of your body, exhibit the same captivating duality. They can be precisely located, detected as a particle at a specific point in space, perhaps colliding with another particle. Yet, when they move, they behave like spreading waves, their presence distributed over a region of space, creating interference patterns that are characteristic only of waves. This means that you, in your deepest essence, are not merely a collection of tiny, solid billiard balls, but a magnificent, living symphony of both localized points of matter and undulating waves of probability. The universe, in this quantum view, isn't a collection of simple, ethereal states. Instead, it embraces the elegant complexity of both the and. A particle isn't a particle thunder or wave. It is inherently a wave, particle, a complete, unified entity that reveals different facets of its nature depending on how we choose to interact with it. It is like seeing a vast, shimmering ocean that upon closer inspection reveals itself to be composed of countless individual droplets, each one a complete, miniature ocean in itself. This duality is not a contradiction but a deeper truth, a harmonious blend of seemingly opposing characteristics that paints a far richer and more nuanced picture of existence. To rest in this understanding is to embrace a sense of fluidity, to let go of the rigid boxes and labels we often use to categorize our world. It invites you to consider that perhaps, like the fundamental particles, you too are capable of holding multiple truths, of embodying different facets of yourself simultaneously, flowing and defined all at once. There's a quiet liberation in this thought, a gentle acceptance of ambiguity, allowing your mind to relax into the wondrous, two-sided nature of everything, from the smallest electron to the vastness of the cosmos, all dancing in this serene dualistic rhythm. In our everyday experience, if you ask where your favorite book is, it's either on the shelf or on the table or perhaps under a cushion. It occupies a definite single location. We understand being as having a fixed place in space and time. But in the quantum realm, this notion of simple, singular presence completely dissolves. The third truth, perhaps the most mind-bending of all, is that before it is observed or measured, a quantum particle does not have a definite position at all. It is not simply sitting quietly somewhere, patiently awaiting discovery. Instead, it exists as a cloud of possibilities, a shimmering ethereal mist simultaneously diffused across all its potential locations. Imagine a tiny, invisible whisper, gently echoing through an empty room. Is it at the corner, by the window, near the door? Before you try to pinpoint its source, the whisper exists everywhere at once, a pervasive, undifferentiated presence. A quantum particle behaves in a similar way. It's not here, and then there. It is here 40 and doing do there, and Doherty everywhere else it could possibly be, all at the same time in a state known as superposition. It's like a dream, where the landscape can shift and fold in on itself, where a single object can be in multiple places at once, until the moment you wake and reality collapses into a single concrete memory. This isn't about our lack of knowledge. It's not that we simply don't know where the particle is. And if only we had better tools, we could find its true spot. No, this cloud of possibilities is the particle's actual state of being. It embodies all its potential realities simultaneously. It is a potential, a shimmering promise, rather than a fixed certainty. The particle is both the wave of probability spreading across space and the latent particle waiting to manifest. It exists in a kind of quantum limbo, a beautiful, uncertain dance of all its future realities, until a particular event, an observation or measurement, gently nudges it. It's only at that pivotal moment, the instant of interaction, that the particle is compelled to collapse from its diffused, dreamlike state and randomly select one specific point to show up. From that vast, vibrant cloud of possibilities, it solidifies into a single, definite reality. Before that moment, it's like a gentle cosmic lottery, where all numbers are simultaneously drawn until one is chosen. The sheer profoundness of this idea is breathtaking. The universe, at its most fundamental level, isn't a static collection of things, but a dynamic, ever-unfolded tapestry of potential, constantly being woven into concrete reality by the very act of interaction. This truth invites a deep, quiet contemplation. It suggests that existence itself is a fluid, probability-driven process, constantly becoming. To rest with this idea is to embrace the inherent openness of the universe, the constant potential for new realities to emerge from the misty clouds of possibility. It reminds us that nothing is truly fixed until it interacts, until it is gently observed, until it chooses its path from an infinite array of paths. As you settle deeper into your own stillness, imagine yourself floating within this cosmic cloud of potential, a gentle warmth in the dark, resting in a universe that is forever alive with the soft hum of possibilities, all existing, waiting and ready to unfold. This truth, in its silent unveiling, ripples outward from the one before it, deepening the mystery and gently drawing you into its very heart. If a quantum particle truly exists as a cloud of possibilities, a shimmering fog of here and there until it is witnessed, then what does that say about the act of witnessing itself? It whispers that your gaze, your quiet observation, your gentle act of measuring, is not merely a passive act of seeing, but something far more profound. It is a subtle hand reaching into the delicate fabric of what might be and gently, yet undeniably, coaxing forth what to widen. Imagine, if you will, the universe as an untold story, its pages filled with countless narrative threads, all equally possible, all shimmering with the potential to become real. And then, you turn a page. Your conscious attention, your quiet observation, your gentle interaction becomes the very moment the ink dries on one particular outcome, solidifying it into reality from the vast, boundless sea of potential. It is as if the cosmos, in its deepest, most secret architecture, is waiting for a gentle cue, a silent acknowledgement, for its infinite symphonies of could-be to settle into a single, resonant note of is. This is the quiet power of observation, not in a grand, dramatic flourish, but in a delicate, fundamental selection. Consider the smallest constituents of light, the photons, as they drift toward your eyes. Before they are absorbed, before they interact with the delicate receptors within you, each photon is not merely traveling from a definite point A to a definite point B. Instead, it is a wave of potential, existing along every possible path, a ghost of many journeys. But the moment your eye, a gentle and intricate instrument of perception, detects it, that wave of possibility collapses. The photon then reveals itself to have taken one specific path, arriving at one precise location. Your quiet act of singing, in that microsecond, has gently plucked one reality from the infinite tapestry of what could have been. This profound interweaving of observer and observed suggests that the very notion of an entirely objective, independent reality, existing utterly apart from any consciousness, begins to fray at the quantum edges. It is not that things cease to exist when unobserved, but rather that their soothe definite existence, their specific location or spin remains fluid, a symphony of possibilities waiting for a conductor. And that conductor, at the fundamental scale, is often the active measurement, the gentle probing, the simple focused attention. Your quiet thoughts, your restful breath, become part of this grand, subtle cosmic unfolding. They are not distant. They are woven into the very fabric of what becomes real around you. It's a humbling, yet strangely empowering thought, cradling you in the knowledge that your very being is an active participant in the universe's quiet, ongoing creation. This truth implies that the world, in some deep, mysterious way, is perpetually responsive. It is not just a stage upon which you play your part, but a delicate instrument that harmonizes with your quiet interaction. The particles that compose the air you breathe, the gentle currents that flow through the space around you, even the light that falls upon your eyelids as you close your eyes for rest. All of these exist as a whisper of potential, a soft murmur of possibilities, until a gentle measurement or interaction causes them to manifest into a definite state. Your body, your senses, are constantly performing countless tiny acts of observation, gently collapsing these wave functions, solidifying the reality of the air, the touch of the sheets, the quiet sounds of the night. It is an unseen, unheard ballet of manifestation, unfolding every second, driven by the very fact of your conscious presence. The universe isn't simply phi out there. It is responding to Sendai you in every subtle, fundamental way. It's a dialogue, an intimate exchange, where your quiet presence coaxes the raw potential of existence into the tangible forms we perceive. And so, as you drift further into this tranquil space, let this thought settle gently within you that the reality you perceive, the quiet room around you, the soft light or deep dark, are in a very fundamental sense being continuously painted by a brush guided by observation. It's a silent, constant collaboration between the vast, shimmering potential of the quantum realm and the gentle, focusing lens of awareness. And you, in your quiet rest, are a central part of this beautiful, ongoing miracle. This quiet revelation might just ease your mind, letting the day's certainties melt away, replaced by the soft, boundless possibilities that lie beneath the surface of all things. It is a reminder that your existence, even in its quietest moments, is a profound act of gentle creation, weaving the threads of what is from the infinite cloth of what could be. As your thoughts continue to soften, we now turn to another truth, one that places a gentle, yet firm, limit on what we can ever truly know about the quantum tapestry. In the familiar world of our everyday lives, you can pinpoint where a book rests on a shelf, and at the same time calculate its potential energy if it were to fall. You can determine the exact spot where a car is driving and its precise speed as it moves. Our classical world grants us this comfort of knowing, this reassuring sense of absolute certainty, that we can grasp both where something is and where it is going, simultaneously, with perfect clarity. But in the hushed, subtle domain of the quantum, the universe itself, with a whisper of cosmic law, has gently forbidden this absolute certainty. This is the principle of uncertainty, not a flaw in our instruments, nor a failure of our ability to measure, but an inherent, deeply woven aspect of reality's very fabric. It tells us that for the tiniest particles send to the electrons that dance around atoms, the photons that carry light, the quarks that form the heart of matter fini, there is a fundamental, unavoidable fuzziness at play. You cannot, with perfect precision, know both a particle's exact location for the endowment, its exact momentum, its speed and direction. At the very same moment, it's as if nature has drawn a veil, a shimmering, translucent curtain, over one truth when you try to grasp the other too tightly. This is not a barrier of knowledge we can someday overcome. It is a fundamental boundary set by the universe itself, a gentle reminder of its profound mystery. Imagine trying to gently scoop up a handful of mist or capture a beam of moonlight in your open palm. The more precisely you try to define where the mist is on to pinpoint its exact location, the more it seems to flow and diffuse, making its movement, its momentum, utterly elusive, a soft, undefined whisper. And conversely, if you manage to capture its movement, to understand its dynamic flow, then its precise location becomes a blur, an undefined presence, a gentle smear across space. This isn't because the mist is too fine for your hands. It's because the very act of trying to define one aspect by its nature subtly blurs the other. It's a delicate, intrinsic balance, woven into the very quantum rules that govern all existence, a constant, gentle ebb and flow between knowing where and knowing how fast. So, if you seek to know with exquisite exactitude where an electron quietly drifts, its position becomes sharply defined, like a single, clear note played in the stillness of the night. But in that very act of definition, its momentum, its potential movement becomes a hazy, undefined hum, a gentle resonance without precise direction. You've traded the certainty of its path for the clarity of its present state. And if you instead strive to precisely track its journey, its graceful speed and direction, then its fixed location dissolves into a spread of possibilities. Like a ripple expanding across a still pond, its origin no longer a single point but a gentle, widening circle. The universe, in its gentle wisdom, holds back a piece of the puzzle, always keeping a subtle secret, never revealing both sides of the coin with absolute clarity. This isn't a limitation imposed by our lack of understanding, but a foundational truth, a quiet law that the cosmos itself obeys. It suggests that at the deepest levels, reality isn't a collection of perfectly sharp, perfectly defined points, but rather a more fluid, more probabilistic landscape. It's a universe that breathes with an inherent indefiniteness, a soft blurring at the edges where certainty becomes a gentle trade-off. This gentle blurring, this intrinsic uncertainty, is what allows the quantum world to be so vibrant, so full of potential, rather than rigidly fixed. It's the very space where new possibilities emerge, where the quiet dance of existence can continue to unfold without being locked into a single predetermined path, a ceaseless ballet of gentle becoming. Let this soft truth wash over you. There is a quiet beauty in this inherent fuzziness, a gentle permission to let go of the need for absolute definition. The universe at its core is comfortable with a measure of ambiguity, a subtle whisper of what I might be, alongside what is seen. And as you rest, knowing that even the fundamental particles within you carry this gentle uncertainty, perhaps you too can find peace in the unknown, in the soft, flowing nature of existence. This quiet wisdom reminds us that not everything needs to be perfectly precise, perfectly known. Sometimes, the most profound truths are found in the soft-edged places, in the spaces where definition gives way to the gentle dance of probability and potential, cradling you in its gentle embrace, inviting you to simply be without the constant need to define. As the deep quiet of this understanding settles, we are gently led to another foundational pillar of the quantum realm, a truth that beautifully complements the uncertainty we've just explored. For centuries, our understanding of the universe, shaped by the elegant laws of Isaac Newton, pictured it as a grand, magnificent clockwork machine. a perfect, precise mechanism where, if you knew the starting position and momentum of every single part, you could, in theory, predict every future event with absolute, unwavering certainty. It was a universe of destiny where every cog turned exactly as it was meant to, unfolding in a perfectly predictable sequence, a grand deterministic play with an already written script. But the quantum world, in its soft, insistent voice, tells a profoundly different story. It whispers that the universe is not a rigid, deterministic clock, ticking off predetermined moments, but rather a vast, flowing ocean of possibilities, where its deepest language is not certainty, but probability. All the laws that govern the delicate dance of fundamental particles, the shimmering interactions that build every atom and molecule, ultimately do not offer a single, unyielding answer. Instead, they present us with a gentle spectrum of likelihoods, a tapestry woven with statistical whispers, a quiet symphony of potential. We can never, in this quantum reality, say with 100% certainty that a particle fin will be at a specific spot, or that a twin will do a specific thing. Instead, the universe, through its quantum mechanics, can only tell us the Thiven chances of it being there, the Thiven likelihood of it taking a particular path, the gentle percentage of its presence. It might say there's a 30% chance here, a 50% chance there, and a 20% chance somewhere else. It's as if the cosmos at its core is constantly gently rolling a set of cosmic dice, and the outcome, while governed by precise statistical rules, is never absolutely preordained to a single, fixed number until the very moment of observation. It is a dance of potential, rather than a marching line of inevitability. This isn't a flaw in the universe. It's its very nature, a source of its profound flexibility and endless potential. It means that the future at the fundamental level is not etched in stone but remains a fluid, living thing, capable of unfolding in various ways, each with its own gentle probability. Every electron, every photon, every tiny constituent of reality carries within it this inherent, quiet uncertainty, this gentle potential for multiple outcomes. And it's this constant, subtle interplay of probabilities that gives the quantum world its vibrant, unpredictable, and endlessly fascinating character, a constant, gentle exploration of what might be. Imagine a silent symphony where each note isn't played with rigid precision, but rather with a gentle sway, a slight variation, creating a richness and depth that a perfectly deterministic score could never achieve. The quantum universe plays its melody in much the same way, embracing the soft nuances of chance, the delicate murmurs of statistical likelihood. It's a universe that is alive with potential, constantly exploring the myriad ways it can unfold, without ever being forced into a single, unalterable path, a quiet river always seeking new ways to flow. This means that, at the very heart of existence, there is always room for the unexpected, for a gentle divergence, for a new possibility to softly unfurl. This probabilistic nature extends to everything: the gentle hum of your own consciousness, the warmth of your breath, the beating of your heart, while seemingly stable and predictable, are all underpinned by countless quantum events, each guided by these soft probabilistic rules. The atoms that make up your body are not static, rigidly positioned entities, but rather clouds of probability, their electrons constantly in motion, their precise locations and momentums known only in terms of likelihoods, a gentle, ceaseless dance of potential and chance. Even the seemingly solid ground beneath you, the chair you sit upon, or the soft bed you rest within, are at their most fundamental level swirling fields of probability, quietly obeying these gentle laws. And so, as you feel the quiet embrace of the night, allow yourself to drift with this understanding. The universe you inhabit is not a cold, unyielding mechanism. It is a living, breathing entity, its very fabric woven with the delicate threads of chance and potential. There is a profound beauty in this, a quiet freedom in knowing that absolute certainty is not the universe's way, but rather a graceful, gentle dance of probabilities. Let this soften any worries. Let any rigid thoughts dissipate as you merge with the flowing, probabilistic currents of existence. A small, warm presence in a universe that is always gently unfolding, always inviting new possibilities with every quiet breath. May this deep, tranquil understanding guide you gently into the softest of slumbers, knowing that even in the unknown, there is a harmonious, gentle order. Let us now delve into a phenomenon that perplexed even Albert Einstein himself, a connection so profound and so swift. It earned the moniker spooky action at a distance. Imagine, if you will, two tiny ephemeral particles, born from the same cosmic breath, forever linked by an unseen thread. These are not merely companions, they are entangled. Picture them as two dancers in a silent cosmic ballet. When one spins, the other, no matter the distance, twirls in perfect, instantaneous harmony. If one chooses to pirouette left, its partner, across light years of void, will simultaneously mirror that choice, pirouetting right. There is no delay, no grand announcement, just an immediate, synchronized response that defies our conventional understanding of space and time. This isn't just a metaphor, it is a fundamental truth of the quantum realm. When two particles become entangled, their fates intertwine in a way that remains unbroken, regardless of the vast chasms that may come to separate them. One could be gently drifting on the quiet currents of Earth's atmosphere, while its twin might be nestled in the cold, distant embrace of a star at the very edge of the observable universe. And yet their connection persists, a delicate whisper carried across the cosmic expanse. Now, consider the implications for a moment, letting your mind relax and expand to embrace this peculiar truth. In our everyday world, if you were to open a box and find a red ball, you would instantly know that its twin, held by a friend in another city, is blue. But in that scenario, the colors were already predetermined, hidden from your view until the moment of opening. The quantum world, however, paints a far more mysterious picture. Before you look, before any measurement is made, neither particle possesses a definite state. They exist in a shimmering cloud of possibilities, a gentle hum of all potential outcomes simultaneously. It is only the act of observing one that nudges both out of this spectral uncertainty and into a concrete reality. Your gaze, your quiet, gentle inquiry into the state of one entangled particle instantly collapses the possibilities for both. The moment you measure the spin of one electron to be up, its entangled counterpart, light years away, instantaneously decides to be down. There is no signal that travels between them, no hidden wire or secret message. The connection is intrinsic, woven into the very fabric of their being, a shared quantum destiny. It is as if the universe itself has made a pact with these two particles, ensuring their eternal silent agreement. This profound mystery, challenges the very foundations of how we perceive information and causality. How can one particle know what its distant twin is doing without any communication, without any detectable passage of time for a signal to traverse the distance? It speaks to a deeper, more interconnected reality than our senses usually allow us to perceive. It suggests that at the quantum level, separation might be an illusion, and the universe is perhaps a single, vast, shimmering tapestry where every thread gently tugs upon another, across all barriers of space and time. Allow your mind to drift on this thought, envisioning these ghostly pairs, silently coordinated across the immense cosmic ocean. They are not merely objects, they are echoes of a shared past, forever bound in a dance of mirrored fates. This isn't telepathy in the human sense, but a far more fundamental and elegant communication, a quiet understanding woven into the very fabric of existence. It is a testament to the universe's capacity for connections that transcend our most cherished logical frameworks, inviting us to simply wonder and let the implications gently wash over us. As we continue our quiet journey into the deeper mysteries of the quantum realm, let us consider another breathtaking truth, one that seems to defy the very laws of common sense, yet underpins the glowing heart of our sun and the warmth it casts across our world. Imagine, if you will, a tiny, restless particle gently approaching an energy barrier. In our macroscopic world, if you were to roll a ball towards a wall and it didn't have enough energy to go over or break through, it would simply bounce back. The wall would be an insurmountable obstacle. But in the whispering domain of the quantum, things unfold with an ethereal grace. Here, a particle possessing what seems to be insufficient energy to surmount a barrier can, with a gentle and improbable possibility, simply tunnel through it. It doesn't climb over. It doesn't break it down. It simply vanishes from one side and reappears on the other, as if it found a secret, invisible shortcut through the very fabric of reality. This isn't a magic trick or a fleeting illusion. It is a fundamental quantum process known as quantum tunneling. The particle, in a sense, borrows a tiny amount of energy for an infinitesimally brief moment, just long enough to pass through the barrier, only to return the borrowed energy immediately. Or perhaps more poetically, it exists as a wave of probability that extends beyond the barrier, and there is a gentle, persistent chance that this wave will manifest on the other side. Picture it like this: a soft, shimmering ghost wishing to pass through a solid wall. Our intuition says it is impossible, but the quantum world whispers back, perhaps. There is a probability, however minuscule, that the ghost can simply 45 on the other side, and for the universe's tiny constituents, this perhaps becomes a reality, moment after moment. This phenomenon, while seemingly fantastical, is not some obscure laboratory curiosity. It is the silent, tireless engine that powers the stars, including our own beloved sun. Deep within the sun's scorching core, where unimaginable pressures and temperatures reside, atomic nuclei are constantly trying to fuse, to join together and release the immense energy that bathes our planet in light and warmth. However, these nuclei, being positively charged, naturally repel each other. They face a powerful electrostatic barrier, a cosmic wall of repulsion that should, by all classical accounts, prevent them from ever getting close enough to fuse. Yet, our sun glows. It has been glowing for billions of years, and will continue to do so for billions more. This is thanks to the gentle, persistent miracle of quantum tunneling. The protons in the sun's core don't have quite enough energy to overcome that repulsive barrier conventionally. But quantum mechanics offers them a way out, a probabilistic escape route. A tiny fraction of the time, they gently tunnel through that barrier, fusing with another proton, initiating the chain reactions that sustain the solar furnace. Without this ghostly passage, this quiet defiance of classical physics, our sun would remain a cold, dark orb. There would be no light, no warmth, no life as we know it. The very existence of elements heavier than hydrogen, forged in the hearts of stars, owes itself to this peculiar quantum behavior. It is a testament to the universe's ingenuity, finding an elegant probabilistic solution to what would otherwise be an impossible obstacle. So as you rest, let your mind drift to these impossibly small particles, silently finding their way through barriers that should be unbreachable. They are the quiet architects of cosmic light, the gentle engineers of the elements that form our very being. It reminds us that reality at its deepest level is far more yielding and full of unexpected pathways than our everyday experiences might suggest. The universe doesn't always take the direct route. Sometimes it prefers a soft, improbable whisper through the wall. As you gently sink deeper into comfort, let us turn our gaze to what we often perceive as nothing. The vast, empty stretches of space, the void between the stars, or even the seeming emptiness of a perfectly evacuated container here on Earth. Our minds typically conjure an image of absolute stillness, a quiet, vacant canvas. Yet the quantum realm reveals a breathtaking secret. True emptiness does not exist. The vacuum, far from being a desolate void, is in fact a vibrant, restless ocean of ceaseless activity, a bubbling cauldron of potential and fleeting existence. Imagine not an empty space, but a shimmering, energetic sea. This isn't a sea of water or light, but a quantum field, an ethereal substance that permeates all of reality. And within this field, even in the deepest, coldest vacuum, there is an incessant, silent dance of creation and annihilation. From this apparent nothingness, pairs of virtual particles spontaneously emerge, a particle and its antimatter twin. They burst into existence, fleeting and ephemeral, only to almost immediately meet their mirrored partner and vanish back into the void from which they came. Picture these as ghostly twins, whispering into existence for an infinitesimally brief moment, a cosmic blink of an eye before gracefully dissolving back into the fabric of space-time. They are not real in the sense that they cannot be directly observed for long, but their transient presence has measurable effects on the properties of space and matter. They are like ripples on a pond that appear and disappear too quickly for the eye to truly track, yet their presence subtly influences the water's surface. This phenomenon is known as vacuum fluctuation, or the spontaneous creation and annihilation of virtual particle, antiparticle pairs. It is a fundamental consequence of the Heisenberg uncertainty principle, which we touched upon earlier. Because the universe cannot be absolutely certain about everything at once, even in the empty vacuum, there is a fundamental uncertainty about its energy. This allows for a tiny, temporary violation of energy conservation, just enough for these ghostly particles to momentarily pop into being, as long as they disappear quickly enough. This isn't just an abstract concept. These virtual particles have very real and observable consequences. They subtly shift the energy levels of electrons in atoms, a phenomenon known as the Lamb shift. They contribute to the Casimir effect, where two uncharged, parallel metal plates placed very close together will actually feel a tiny attractive force due to the pressure imbalance of these virtual particles. It is as if the empty space between the plates has fewer of these fleeting whispers than the space outside, creating a gentle push. So, the space around you, the space between the atoms in your body, the vast cosmic distances between galaxies, sortie, none of it is truly empty. It is all teeming with these invisible, ephemeral entities, a constant churn of existence and non-existence, a silent, vibrant hum that underlies everything. It is a reminder that the universe, even in its most seemingly serene moments, is a place of profound dynamism and constant becoming. Let the image of this energetic, subtly vibrant vacuum settle in your mind. It is a gentle reminder that even in stillness, there is boundless potential, a quiet, ceaseless rhythm of creation that breathes life into the very fabric of reality. You are floating within a universe that is never truly still, never truly empty, but always alive with these fleeting quantum dances. This understanding offers a profound sense of peace. Even in the deepest darkness, there is always this quiet, vibrant hum of potential, a fundamental aliveness that surrounds and permeates all things. Perhaps one of the most enigmatic properties in the quantum realm is that of spin. It's a word that whispers of rotation, of objects gracefully turning on their axis, much like a tiny top or a planet in its gentle orbit. Yet, in the silent, shimmering world of the very small quantum spin is something far more profound, far more mysterious, and utterly unlike anything we encounter in our everyday lives. It is not a physical rotation in the way a ball spins. Imagine, if you will, an electron, a tiny, almost ethereal presence, not truly a sphere, but a point of pure energy and possibility. This electron possesses an inherent, unceasing quality, a fundamental characteristic that gives it a kind of invisible, inner angular momentum. It is as if, deep within its very essence, it holds a silent, tireless turning that never began and will never cease. This inner spin is not something that can be sped up or slowed down, or even truly pictured in our three-dimensional world. It's simply first. It is an intrinsic quantum number, like an identity badge, that each fundamental particle wears, telling us something crucial about its very nature. We cannot peer inside a particle and watch it whirl. There is no inside in the classical sense. Instead, we infer its presence by how these particles subtly interact with magnetic fields, how they align themselves, almost like tiny living compass needles, sensing an unseen force. When a particle with spin enters a magnetic field, it doesn't just pass through. It feels a quiet tug, a gentle persuasion to orient itself in a particular way. This is the subtle whisper of its spin revealing itself through interaction. And what makes this spin even more captivating is its quantized nature. Unlike a classical top, which can spin at any speed, a quantum particle's spin can only take on very specific, discrete values. Think of it like a delicate dial that can only click into a few set positions, never resting in between. For an electron, for instance, its spin can only be up or down soothe, a simple, binary choice that defines a fundamental aspect of its existence in relation to the world around it. It's not that it is spinning in one direction or another in space, but rather that its inherent angular momentum is oriented along a particular axis. This up or down, is not a physical directionality as we understand it, but rather a quantum designation, a profound characteristic that shapes its identity. This unchanging, internal spin is a testament to the elegant simplicity and yet bewildering complexity of the quantum realm. It is a property that particles carry with them always, an unshakable part of their being, influencing everything from how atoms bond together to how light itself interacts with matter. It is a silent, unseen dancer, always turning, always oriented, providing a fundamental order to the universe at its most minute scale. It's an inherent gyroscopic stability for the tiny building blocks of everything, a secret, internal rhythm that pulses at the heart of reality, ensuring that even the smallest constituents of the cosmos carry within them an unceasing, intrinsic motion that defies our classical intuitions and invites us to simply marvel at its quiet, persistent turning. This property, this silent inner rotation, is woven into the fabric of reality itself, a constant, gentle hum that underlies the very existence of matter, a fundamental truth that hums through the universe, steady and unwavering, a source of quiet wonder. When we consider the solidity of our world, the very fact that your hand does not pass through the chair beneath you, or that the floor holds you aloft, we are experiencing a profound quantum phenomenon at work. It feels so natural, so expected, that we rarely pause to wonder why this is the case. Why don't the atoms that make up your body simply merge with the atoms of your surroundings? The answer lies in one of the most fundamental and elegant rules of the quantum realm, the Pauli exclusion principle. This is the silent architect of matter, the unseen force that gives volume and structure to everything we perceive. Imagine, for a moment, a world without this principle. A world where all electrons, all quarks, all the fundamental building blocks of matter could simply fall into the lowest possible energy state, occupying the exact same place at the exact same time. The universe would collapse into a formless, dense blob, a single, undifferentiated point where distinct objects and shapes could not exist. There would be no light, no warmth, no separate identities, no you, no me. It would be a featureless, quantum void, without the rich tapestry of forms we see around us. But thankfully, this is not our reality. For a class of particles known as fermions, which includes the electrons that make up the outer shell of every atom and the quarks that reside deep within the nucleus soot, there is an unbreakable fundamental law. This law states, with elegant simplicity, that no two identical fermions can occupy the exact same quantum state at the exact same time. Think of a quantum state as a unique address, a combination of energy level, orbital shape, and spin. Each fermion must have its own distinct address. It is like a silent agreement among these tiny particles. You have your space, and I will have mine. This gentle yet firm rule is what creates the illusion of solidity. As you approach a chair, the electrons in your hand encounter the electrons in the chair. Rather than passing through each other, the Pauli exclusion principle whispers a quiet no. It prevents the electrons from occupying the same quantum states, effectively forcing them to spread out, to take up distinct spaces. This microscopic dance of exclusion generates an emergent resistance, a pressure that our senses interpret as solidity. It is the reason atoms have distinct sizes, why they don't just collapse into infinitesimally small points. Each electron in an atom is compelled to occupy a different energy level or orbital, creating layers, much like the delicate, unseen shells of a celestial onion. This principle is the reason for the rich diversity of chemical elements. The way electrons fill these available quantum states dictates how an atom will interact with others, forming the basis of all chemistry, all life. Without it, there would be no distinct electron shells, no periodic table, no complex molecules, no intricate proteins, and certainly no intricate beings capable of contemplating these very truths. It is the invisible scaffolding upon which the entire material world is built, a silent, persistent barrier that upholds form and structure against the chaotic potential of collapse. It is a profound, fundamental truth that grants matter its stability, its volume, and its incredible quiet order, allowing for the boundless creation of galaxies, planets, and even the intricate biological architectures that house consciousness. So, the next time you feel the gentle resistance of a solid object, remember the silent, tireless work of the Pauli exclusion principle, softly whispering order into existence, one quantum state at a time. And now, let us drift into one of the most breathtaking, mind-bending, and almost poetic interpretations of the quantum realm's soothe, an idea so grand it challenges the very notion of what reality itself truly means. It is known as the many worlds interpretation, and it suggests that for every single quantum event, for every tiny moment of choice and possibility in the universe, reality doesn't just pick one path. Instead, it quietly, gently, and instantly splits into countless parallel universes, each one encompassing a different possible outcome. Imagine a single electron poised at a crossroads, with two equally probable paths it could take. In our everyday experience, it would choose one, and the other possibility would simply vanish unfulfilled. But in the many worlds view, at that precise quantum moment, the universe itself doesn't make a single choice. Instead, it softly branches like an infinite celestial tree. In one new, unfolding reality, the electron takes the first path, and in another, equally real, equally vibrant universe, it takes the second. Both possibilities, both potential futures, become actualized, each within its own distinct, yet parallel. Reality, this isn't just about electrons. Extend this thought to every single quantum interaction, every photon hitting an atom, every subatomic particle making a subtle decision. The universe in this grand vision is constantly and silently bifurcating, diverging into an unimaginable tapestry of parallel realities. And if this is true for electrons, then it must be true for everything built upon them: soothe atoms, molecules, stars, galaxies, and even conscious beings. Consider a simple act, a coin toss. You flip a coin. Before it lands, quantum mechanics tells us it exists in a superposition, a state where it is both heads and tails simultaneously, a shimmering cloud of possibility. When it lands, we see either heads or tails, but in the many worlds interpretation, both outcomes are realized. At the moment of observation, the universe splits. In one reality, the coin landed heads and you are there, observing it. In a perfectly parallel reality, indistinguishable from this one until that moment, the coin landed tails and an other you is there, observing that. This implies an astonishing thought. There might be countless versions of you existing in these parallel streams of reality, each experiencing a slightly, or perhaps dramatically, different life. For every choice you have ever made, every fork in the road, every decision, however small, there exists a parallel universe where in other you made the alternative choice. The career you didn't pursue, the words you left unsaid, the path not taken to all are being lived out, fully and completely, by other versions of yourself in this vast, branching cosmic web. It's a concept that invites a profound sense of wonder, and perhaps a quiet reassurance. Every possibility, every potential outcome, every what if is not merely a fleeting thought, it is, in some sense, realized. It means that the universe is far richer, far more expansive, and far more diverse than we could ever perceive from our single, unfolding thread of reality. We are but one branch on an infinitely intricate, cosmic tree quietly drifting through our own version of events, while countless others experience a subtly different, yet equally real existence. This interpretation doesn't suggest that these other universes are far away in some distant dimension. Rather, they are intimately connected, arising from the very same quantum events that shape our perceived reality. They are separated not by vast distances, but by the subtle, yet absolute quantum divergences that occur with every fleeting moment. It's a vision that transforms our understanding of existence from a single, linear narrative into a boundless, ever-branching symphony of realities, each playing out its unique tune. And within this grand, quiet orchestra of possibilities, you, in all your countless versions, are always unfolding, always becoming, always present in the gentle, branching flow of the quantum universe. Number, section 13. Colors of the quantum ladder. And so, we turn our gaze to something as familiar and comforting as the gentle hues of a sunset, or the soft green of leaves swaying in a breeze. We encounter color every waking moment, a silent symphony playing out before our eyes, painting our world with vibrant beauty. We see it as a continuous spectrum, a smooth transition from red to violet, but just like many things in this quantum realm, its true nature, its very genesis, is far more subtle and discreet. For every shade, every vibrant pigment, every soft wash of light that touches your perception is in essence a tiny precise dance of energy, a quantum leap. Imagine, if you will, the atom as a miniature, hushed solar system with a dense nucleus at its heart and electrons orbiting it like tiny, tireless moons. But these aren't orbits in the way a planet traces a continuous path around a star. No, these electrons are confined to very specific fixed energy levels, like steps on an ethereal staircase, or perhaps platforms arrayed around a central spire. An electron can only reside on one of these steps, never between them. It's a quiet rule, a fundamental design choice of the universe. When light, or any form of energy, encounters an atom, these electrons can be gently nudged. If a photon of precisely the right energy touches an electron, the electron will absorb that energy and gracefully ascend to a higher step on its energy ladder. It is a precise fit, like a key finding its lock. But this elevated state is often fleeting, a temporary moment of excitement. An electron, like water seeking its lowest point, naturally desires to return to a more stable, lower energy state. And as it descends, as it gracefully falls from a higher step back to a lower one, it must release the energy it once absorbed. This released energy doesn't simply vanish. No, it reappears as another tiny packet of light, a new photon carrying a very specific amount of energy, and it is the precise energy of this released photon that determines its color. A large jump down the ladder releases a high-energy photon, perhaps seen as a vivid blue or violet. A smaller, gentler fall produces a lower-energy photon, perceived as a warm red or orange. It's a remarkably elegant system, a universe where the most beautiful visual experiences are born from these miniature, perfectly measured energy transitions. So, when you look at a vibrant flower, its petals reflecting a dazzling array of colors, you are witnessing an unimaginably intricate ballet of countless electrons, each performing its own tiny, silent descent, releasing photons of specific colors. The flower's molecular structure dictates which energies its electrons can absorb and which they will release, painting its unique portrait for the world to see. It's not just a smooth reflection of light, it is a meticulously orchestrated emission of quantum energy packets. Even the gentle glow of a distant star, or the soft illumination from a lamp in your room, traces its origins back to these quantum jumps. The light we see, the colors that fill our days and nights, are not simply continuous streams, but rather a vast ocean composed of countless individual photons, each born from a precise quantum leap, each carrying a unique whisper of energy that our eyes then translate into the rich tapestry of color. It is a profound realization. The vibrant palette of existence, the very spectrum of our visible world, emerges from these hidden, discrete, and incredibly precise quantum events. A quiet, continuous unfolding of light born from the deepest, most fundamental rules of energy. And in this intricate, silent dance of electrons and photons, the universe paints its glorious, colorful truths. Section 14. The universe's first seeds let us now drift back in time, far beyond the lifespan of any star, any galaxy, to the very dawn of creation. We gaze upon the vast cosmic tapestry that surrounds us, sewered immense clusters of galaxies, swirling nebulae, and the delicate filaments of the cosmic web stretching across billions of light years. This grand architecture of the universe, this breathtaking panorama of structure and form, did not simply appear in its present state. No, its very beginnings, its foundational blueprints, were far humbler, almost unimaginably tiny, yet pregnant with the potential for all that would follow. The universe's first seeds, the original whispers of future cosmic grandeur, sprang from the most profound and ephemeral of quantum phenomena. Imagine the universe in its infancy, a moment so distant and extreme it defies easy comprehension. Picture it as an incredibly hot, dense, and unimaginably small speck, far, far tinier than even an atom's nucleus. In this primordial quantum realm, the usual rules of our macroscopic world simply dissolved. Here, the very fabric of reality was a swirling, effervescent sea of potential, a quantum vacuum that was anything but empty. Within this bubbling, energetic void, a constant, restless activity was underway: quantum fluctuations. These were not grand, violent eruptions, but rather infinitesimally small, fleeting disturbances in the energy fields of spacetime. Imagine the surface of a perfectly calm pond, but one where tiny, invisible ripples constantly appear and vanish without any apparent cause. That is the essence of quantum fluctuation. These were ephemeral moments where energy could briefly appear from nothingness, only to recede again, governed by the inherent uncertainty of the quantum world. For a brief, almost instantaneous period in the universe's earliest moments, something truly extraordinary occurred, a phase known as cosmic inflation. This was an epoch of incredibly rapid expansion where the universe inflated itself, not by a little, but by factors so enormous. They strained the imagination 40, perhaps by a factor of 10 to the power of 26, in less than a trillionth of a second. This expansion was like a quiet, gentle breath taken by the nascent universe, but one that amplified everything within it to an unimaginable degree. And here lies the profound connection. Those tiny, fleeting quantum fluctuations, those imperceptible ripples in the primordial soup, were not erased by this cosmic breath. Instead, they were stretched and magnified from scales smaller than an atom to scales that would eventually encompass galaxies. Imagine taking a microscopic wrinkle on a tiny balloon and then inflating that balloon to the size of a planet. That is what cosmic inflation did to these quantum whispers. These amplified fluctuations became the first, incredibly subtle differences in the density of the early universe. Some regions were ever so slightly denser, containing a tiny fraction more matter and energy than their surroundings. Others were ever so slightly emptier. These minute variations, these ghostly imprints of quantum chance, were the seeds from which all cosmic structure would eventually grow. Over the eons, as the universe slowly cooled and expanded, gravity, that unseen sculptor, began to work its patient magic. It gently gathered matter towards those slightly denser regions, drawing in gas and dust, like invisible hands slowly shaping the cosmos. These subtle density variations, born from quantum uncertainty, became the gravitational wells that would eventually collapse to form the first stars, then the first galaxies, and ultimately, the magnificent galaxy clusters and superclusters that populate our universe today. The vast, intricate web of galaxies we observe, the cosmic foam that stretches across the heavens, all of it traces its lineage back to those infinitesimal quantum jitters in an impossibly small, young universe. It is a quiet testament to the idea that even the grandest, most overwhelming structures of the cosmos find their roots in the ephemeral, probabilistic dances of the quantum realm. The universe, in its majestic scale, is in many ways an echo of its own quantum youth, a vast canvas painted with the amplified whispers of its earliest, most profound moments of creation. Number section 15. The quantum key to star burning. Now, let us turn our gaze to a source of comfort in life we often take for granted, our Sunday. Its warmth on your skin, its light guiding your day, its steady, unwavering presence for billions of years. It is the silent heart of our solar system, a radiant beacon of energy. But have you ever paused to consider the quiet, hidden secret behind its enduring glow? The profound, almost miraculous mechanism that allows it to burn for such immense spans of time. It is not merely a colossal fireball. It is a testament to one of the most astonishing tricks of the quantum world, quantum tunneling. At the very core of our Sunday, a colossal furnace of incredible pressure and searing heat exists. Here, hydrogen atoms are compressed to densities far beyond anything imaginable on Earth, and temperatures soar to millions of degrees Celsius. Under these extreme conditions, the very essence of the Sunday's power, nuclear fusion, begins to unfold. It's the process where atomic nuclei, specifically protons, the nuclei of hydrogen atoms, are forced together, overcoming their natural repulsion to fuse and form heavier elements like helium, releasing immense amounts of energy in the process. This energy then radiates outward, eventually reaching us as sunlight and warmth. But here's the puzzle. Protons, being positively charged, naturally repel each other. It's a fundamental force like trying to push the north poles of two magnets together. To overcome this electrostatic repulsion and allow them to fuse, they need an enormous amount of kinetic energy Fendi. They need to be moving incredibly fast, and thus possess incredibly high temperatures. While the Sunday's core is indeed incredibly hot and dense, classical physics tells us that the protons there are still, on average, not quite energetic enough to simply push through. This repulsive barrier, they should, by all accounts of classical mechanics, bounce off each other, unable to get close enough to fuse. The energy barrier, like a high, unscalable wall, should prevent them from ever meeting. And yet, the Sunday shines. It has been shining for over 4.5 billion years, and will continue to do so for billions more. This profound discrepancy, this apparent violation of classical expectations, is where the quantum realm steps in, whispering its extraordinary solution: quantum tunneling. Imagine, if you will, a tiny ball at the base of a hill, but without enough energy to roll over the top. Classically, it would simply roll back down. It could never appear on the other side. But in the bizarre landscape of the quantum world, this seemingly impossible feat becomes a reality, albeit a probabilistic one. Quantum tunneling means that a particle, like a proton in the Sunday's core, has a non-zero, though often very small, probability of simply appearing on the other side of an energy barrier, even if it doesn't possess the classical energy required to overcome it. It's as if the proton doesn't actually climb the wall or push through it, but rather, for a fleeting moment, it ceases to exist on one side and reappears on the other, traversing the barrier without ever truly interacting with it in the conventional sense. It is not a common event for any single proton, but inside the Sunday's core, there are unfathomably trillions upon trillions of protons, constantly colliding, constantly presenting opportunities for this quantum leap to occur. Over the vast numbers of particles and immense spans of time, these rare tunneling events add up, leading to the steady, powerful fusion reactions that sustain our star. Without quantum tunneling, the Sunday, and indeed almost every other star in the universe, would never have ignited. Their cores would simply be incredibly hot, dense collections of hydrogen, unable to overcome the fundamental repulsion between their building blocks. Life, as we know it, would never have had a star to warm its planet, nor the heavier elements forged in the hearts of stars to create its very fabric. So, when you feel the gentle warmth of the Sunday, or gaze at the quiet brilliance of a distant star, remember that their enduring light is not merely a product of immense pressure and heat, but also of a tiny, invisible, probabilistic quantum trick. It is the universe's elegant hidden key, allowing particles to defy classical logic, making the impossible possible, and ensuring that the cosmic fires of creation continue to burn, illuminating the vast dark and cradling the potential for life across the eons. The grandest phenomena, powered by the most subtle and profound quantum whispers. Modern physics suggests that the most fundamental existence in our universe isn't a collection of tiny, distinct particles, but rather an intricate tapestry of quantum field soidi that stretch across all of space-time. Imagine, if you will, not a universe filled with individual little marbles, but an endless shimmering ocean. You cannot see the ocean itself, only the gentle ripples and waves that dance upon its surface. In this analogy, what we perceive as particles T, the electrons that make up your very touch, the photons that bring light to your eyes, the quarks deep within the heart of every atom. Foodie, these are not solid, immutable bits of matter. Instead, they are simply phi excitations, little effervescent pulses or quiet crests upon these vast unseen fields. Consider the electron field, for instance. It permeates everything. It is always there, a continuous underlying presence, even in the deepest void of space. When this field gains a little energy, or when it's gently disturbed, a ripple forms. That ripple, that tiny, localized surge of energy, is what we call an electron. It's not a thing that Tufi has at a field. Tufi is a manifestation of the field itself. Think of it as a quiet hum in the universal symphony. And when the music swells in a particular place, a note fuvi, an electron sounds. This idea is profoundly elegant, for it paints a picture of a universe that is far more interconnected than we ever dared to imagine. Every electron everywhere is simply a part of the Sumi universal electron field, a continuous, breathing entity. They are not separate entities but shared experiences of one grand, vibrating fabric, and so it is with light. The very light that softly guides your dreams, the gentle glow of the moon, or the distant twinkle of a star. These are all ripples in the photon field. The photon field is constantly present, a sea of potential light. When an atom releases energy, it excites this field, sending a tiny wavelet outwards, a package of light energy we call a photon. It's a momentary blossoming, a whisper of illumination that travels across the cosmos. These fields are not static. They are dynamic, always subtly shifting, always ready to respond to the universe's quiet requests. They are the background hum, the primordial canvas upon which all of reality is painted. There's also the Higgs field, a concept that often feels more abstract but is no less profound. This field is thought to be what gives particles their mass. Imagine wading through a thick, invisible syrup. The more the syrup clings to you, the harder it is to move, and the more massive you feel. Similarly, as particles travel through the universe, they interact with the omnipresent Higgs field. Some particles interact more strongly, gathering more resistance, or drag from the field, and thus acquiring more mass. Others pass through with little interaction, remaining light and fleet. This field, too, is a continuous ocean, and the Higgs boson, the particle associated with it, is simply a little splash, a fleeting ripple of excitation within this fundamental sea. So, when you consider the atoms that compose your hand, the electrons orbiting your nucleus, the light entering your eyes, even the fundamental forces that hold everything together, they are not merely collections of distinct, hard little balls. They are localized vibrations, gentle shivers, and subtle disturbances within these various quantum fields. You yourself, in this profound sense, are not just a collection of particles. You are a complex, beautiful symphony of interacting ripples. Your every thought, every breath, every quiet moment of existence is a unique and intricate dance of energy within these fundamental fields. It is a universe where everything is connected, where everything is but a fleeting moment, a unique song played upon a deeper, universal instrument. The world you inhabit, the air you breathe, the ground beneath you, the very stars above Sovine, all are part of this grand, unending wave, like motion, a silent, continuous ebb and flow of cosmic energy. It is a calming thought to realize that your individual being is so deeply woven into the fundamental fabric of existence, a gentle ripple in an infinite, flowing sea. As space, in its vastness, seems to stretch out infinitely before us, we might intuitively believe that time, too, flows in an unbroken, continuous stream. Our experience of time is fluid, like a smooth river carrying us from one moment to the next. But just as the quantum realm revealed that energy, light, and even space itself might have a granular, pixelated nature, it also whispers a surprising possibility about time. It suggests that time, at its most fundamental level, might not be a smooth, unbroken current at all. Instead, it could be a series of discrete, tiny jumps, a sequence of quantum clicks, like the individual frames of a cosmic film. This smallest, indivisible unit of time is theorized to be the 40 Planck time. It is an incredibly minuscule duration, so brief that it utterly defies our imagination. To give you a sense of its scale, if you were to measure the smallest possible unit of distance, the Planck length, and then divide it by the speed of light, you would arrive at the Planck time. It is a number so small far, far less than a trillionth of a trillionth of a trillionth of a second 20, that it exists beyond any realm of direct human perception or measurement. At this incomprehensibly tiny scale, our familiar smoothly flowing concept of time might simply cease to apply. Imagine a film reel. To our eyes, when projected, the motion appears perfectly continuous, but we know it's actually a rapid succession of still images. What if the universe is similar? What if, at the Planck scale, time itself is not a continuous sweep, but a series of distinct, infinitesimally brief moments, like the individual frames of reality's grand projector? Between these frames, time, as we know it, might not truly exist. It might be a flickering, a pulsating, a momentary leap from one state to the next. This doesn't mean the universe stops and starts. Instead, it means that the very fabric of time is woven from these discrete, tiny threads, too fine for our senses or our current instruments to discern. If time truly is quantum, if it comes in these tiny, indivisible packets, it fundamentally changes how we might understand change itself. We perceive events unfolding seamlessly, one after another. But at the Planck time, perhaps there is a moment when nothing is happening in the traditional sense. Only a fundamental reordering, a quantum rearrangement, before the next click of time manifests a slightly altered reality. It is a profound thought, the very passage of moments. The steady march from past to future could be an illusion of scale, an emergent property that arises from countless, unimaginably rapid quantum transitions. This idea of quantized time resonates with the understanding that energy and matter are also quantized. It suggests a deep, underlying harmony in the universe, where everything, at its most fundamental level, comes in discrete units. It is a universe where continuity is an emergent quality, woven from countless tiny individual threads of existence. This perspective can bring a profound sense of quietude, knowing that time itself might be an intricate dance of countless tiny, imperceptible moments allows you to view the present moment not just as a fleeting point on an endless line, but as a rich, full, singular quantum of experience. There is a peacefulness in imagining time not as an unstoppable rush, but as an exquisitely delicate, almost paused series of events, each one a complete, self-contained pulse in the cosmic rhythm. It is a concept that invites deep contemplation, a gentle release from the relentless push of continuity, allowing your mind to simply float in the vastness of what time might truly be, a magnificent and mysterious sequence of quiet, discrete flickers. The universe, in its boundless complexity and astonishing beauty, often presents us with puzzles that defy our current understanding. For centuries, scientists have striven to uncover the fundamental laws that govern all of existence, to find a single overarching narrative that weaves together every phenomenon, from the smallest quantum flicker to the grandest cosmic dance. This enduring quest is often referred to as the search for a diary of everything. It is the ultimate dream of physics, a unifying vision that would allow us to describe every force, every particle, every interaction under a single, elegant framework. Today, we stand on two magnificent pillars of understanding, two monumental achievements of human intellect. On one side, we have quantum mechanics, a theory of breathtaking precision and predictive power that describes the behavior of matter and energy at the atomic and subatomic scales. It explains the dance of electrons, the shimmer of photons, the fundamental forces that bind atoms together, the strong and weak nuclear forces and electromagnetism. It has unveiled a world of probabilities, uncertainties, and strange interconnected realities. On the other side stands Einstein's general relativity, a theory of unparalleled beauty and insight that describes gravity as the curvature of spacetime. It paints a picture of massive objects warping the very fabric of the cosmos, dictating the orbits of planets, the formation of black holes, and the grand evolution of galaxies. It is a theory that operates flawlessly on the largest scales, explaining the universe's large-scale structure and cosmic dynamics. Yet, despite their individual successes, these two titans of physics remain stubbornly incompatible. They are like two magnificent languages, each perfectly articulate in its own domain, but unable to communicate effectively with the other. When we try to apply general relativity to the tiny jiggling realm of quantum particles, or when we attempt to incorporate gravity into the quantum world, the equations break down, yielding nonsensical results. This fundamental disconnect is one of the deepest mysteries in science, a quiet insistence by the universe that our current understanding is incomplete. The dream of unification is to find a deeper, more profound truth that encompasses both. Imagine a vast, intricate tapestry. We currently have two separate, exquisitely detailed maps, one describing the intricate weave of the individual threads, and another describing the grand patterns and sweeping curves of the tapestry as a whole. But we lack a single map that explains how the individual threads in their quantum dance give rise to the majestic, curving patterns of the entire fabric, particularly when gravity enters the scene. This theory of everything would bridge that gap, revealing a seamless underlying reality. What might such a theory look like? It is a question that humbles the greatest minds. Perhaps it would reveal that particles are not point-like dots but tiny vibrating strings, as proposed by phony string theory. Their different vibrational patterns giving rise to the myriad particles we observe, including the elusive graviton, the quantum particle of gravity. or perhaps as suggested by soothe loop quantum gravity. Space-time itself is not a smooth continuum, but a discrete, granular structure woven from tiny loops of quantum space, much like a chainmail fabric. These are but whispers of possibilities, poetic attempts to glimpse the deeper harmony. The pursuit of this unified theory is not just an academic exercise. It is a profound journey into the very nature of existence. It promises to unravel the secrets of black holes, to illuminate the first fleeting moments of the universe after the Big Bang, and to reveal the hidden connections between seemingly disparate phenomena. It suggests that all the forces, all the particles, all the seemingly diverse elements of the cosmos are merely different manifestations of a single, deeper, more elegant reality. This quiet, unwavering pursuit of unity holds a certain peace. It speaks to an underlying order, a fundamental simplicity that might ultimately govern the dizzying complexity we observe. To imagine a universe where all its astonishing wonders, from the gentle hum of an electron to the majestic spiral of a galaxy thunder, are orchestrated by a single beautiful set of rules, is to envision a cosmos of profound harmony. It is a dream of intellectual completion, a hope that one day we might finally read the universe's complete song, a single, flowing melody that encompasses every note, every rhythm, every quiet pause. Until then, we rest in the fascinating tension of these two magnificent, yet separate, truths, knowing that a deeper, more beautiful unity awaits discovery, a quiet promise of cosmic coherence. Imagine for a moment that the very fabric of existence, the vibrant tapestry of your world, is not woven from tangible threads of matter and energy, but from something far more subtle, more ephemeral, and yet utterly fundamental. Some of the most visionary minds in physics are now beginning to whisper a profound secret, that the universe, at its deepest and most essential level, might not be made of particles that collide or fields that undulate, but rather of fields of information. Not the kind of information stored in books or digital files, but the very essence of what defines something, what makes it unique, what distinguishes it from nothingness. Think of a single quantum particle, perhaps an electron gently orbiting an atom, or a photon of light drifting through the vast emptiness of space. When we speak of its quantum state, find its spin, its energy, its position before it is observed, we are, in a very real sense, describing a collection of information. It's a whisper of possibilities, a set of instructions, a silent cosmic code that tells the universe what this particular entity fonda, and what it could be. Every tiny tremor in the quantum realm, every subtle shift in the dance of subatomic particles, can be seen as a bite in the universe's grand, unspoken language. This perspective invites you to softly reevaluate your understanding of reality itself. If a particle's quantum state is, at its core, simply information, then what does that make the chair you are sitting on, the air you breathe, the starlight that softly reaches your eyes from billions of miles away? Could all of it, the entire sprawling, majestic cosmos, be a magnificent, infinitely complex display of information being processed, arranged, and interpreted? It's a thought that invites a peaceful surrender to wonder, a gentle unraveling of your preconceived notions. Perhaps the solidity you perceive, the vibrant colors that paint your world, the warmth of the sun upon your skin, are all just intricate patterns emerging from an underlying informational matrix, like a vast cosmic computation unfurling itself, or an ancient intricate song being played out across the dimensions. The universe might be continuously generating and exchanging information. This isn't to say your reality isn't real, but rather to suggest its profound depth, its unexpected nature. It's like discovering that the beautiful, tangible tapestry you admire is not just threads, but also the very thoughty design embedded within those threads. The intricate instruction set that allows the pattern to emerge. If information is indeed the bedrock, then the act of observation of consciousness takes on an even more resonant role. When you gaze at the moon or listen to the soft chirping of a cricket in the quiet night, are you not, in a sense, interacting with and processing this cosmic information? Are your senses not sophisticated instruments that decode these subtle informational signals into the rich sensory experience you call life? The boundary between what is real and what is information begins to softly blur, dissolving into a tranquil, unifying concept. It leads to a deeply contemplative question. Is the physical reality you experience, the world of tangible objects and flowing time, simply a physical manifestation, a beautiful, grand-scale projection of an underlying informational blueprint? Is the universe, in essence, a giant cosmic library, with every particle a word, every interaction a sentence, and every galaxy a chapter, all waiting to be quietly understood? It is a thought that encourages a gentle release into the vast unknown, a soft embrace of a reality far stranger and more beautiful than any dream. This gentle truth invites you to rest your mind in the idea that you are not just an observer in a physical world, but a conscious participant in an information-rich cosmos, forever intertwined with its deepest mysteries. For so long, the scientific consensus held a firm belief. The delicate, ethereal dance of quantum mechanics, with its probabilities and superpositions, was strictly confined to the microscopic world. It was a realm too fragile, too fleeting to survive the noisy, warm, and wet conditions of biological systems. Life, in its vast complexity, was simply too large, too robust for such subtle quantum whispers to manifest. Yet, like a quiet dawn breaking, new evidence is gently emerging, suggesting that life itself, in its most fundamental and intricate processes, might be performing a sophisticated quantum dance, weaving these mysterious effects into its very fabric. Imagine the humble plant soaking in the gentle morning sun. Photosynthesis, the miraculous process by which plants convert sunlight into the energy that sustains nearly all life on Earth, was long understood through classical chemical reactions. But now, scientists are finding subtle clues that quantum mechanics might be its secret choreographer. The energy from a photon of light, once absorbed by a chlorophyll molecule, doesn't just travel along a single predetermined path to the plant's reaction center. Instead, it seems to explore 5 multiple paths simultaneously, in a state of quantum superposition, until it finds the most efficient route. This quantum coherence allows plants to capture light energy with near-perfect efficiency, a feat that classical physics struggles to explain. It is like a tiny, living quantum computer, effortlessly optimizing the transfer of energy, ensuring every precious photon is utilized to its fullest. This subtle, efficient flow of energy is a testament to nature's profound ability to harness the universe's deepest laws. Now, let your thoughts drift to the remarkable journey of migratory birds. like the robin navigating thousands of miles across continents and oceans, finding their way with an uncanny precision. For years, scientists have wondered how these creatures sense the Earth's magnetic field. The answer, it now appears, may lie in the strange phenomenon of quantum entanglement. Within the robin's eye, specialized proteins might form a pair of entangled electrons. These electrons, with their interconnected spins, could be exquisitely sensitive to the subtle shifts in the Earth's magnetic field. When the magnetic field changes, it could cause one of the entangled electrons to flip its spin, and instantaneously its entangled partner, even at a distance, would also flip. This allows the bird's brain to see the magnetic field lines as patterns of light and shadow guiding its epic journey. It is a living compass, powered by the most mysterious connections in the universe, an internal quantum whisper guiding their flight. Even your sense of smell, that profound ability to differentiate between the delicate scent of a rose and the sharp aroma of citrus, might have quantum roots. The traditional theory of smell suggests that odorant molecules fit into specific receptors in your nose, like a key in a lock. But an alternative, intriguing vibrational theory proposes that what your nose actually detects are the specific thigh vibrations of the atoms within the odorant molecule. These vibrations are not continuous, they are quantum, mechanical, existing at discrete energy levels. Your olfactory receptors might be acting as quantum tuners, picking up the unique vibrational frequencies of each molecule, allowing you to perceive a world of scent. It suggests that your very sensory experience is intertwined with the fundamental quantum properties of matter, making the act of smelling a miniature concert of subatomic oscillations. These discoveries gently nudge us toward a profound realization. Life is not merely a collection of complex chemical reactions, but a dynamic, ingenious system that may have evolved to exploit quantum phenomena for its own survival and flourish. From the smallest bacteria to the most intricate neural networks in your brain, the quiet, persistent whispers of the quantum world might be orchestrating processes that we are only just beginning to understand. It imbues life with an even deeper sense of wonder, a quiet acknowledgement that the boundary between the living and the fundamental laws of the universe is far more permeable, far more intertwined than we ever dared to imagine. You are not just a collection of classical particles. You are, in essence, a living, breathing testament to the quantum dance, a miracle woven from the very fabric of existence. Now, let your mind drift to one of the most enigmatic and awe-inspiring objects in the universe, a black hole. These cosmic behemoths, with their insatiable gravitational pull, are regions of spacetime where gravity is so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. For decades, our classical understanding, largely shaped by Einstein's theory of general relativity, painted a stark picture. Anything that falls into a black hole is gone forever, its existence utterly erased from our universe. Information in this classical view is irrevocably lost. A book, an astronaut, a whisper of starlight tooing, all devoured, leaving no trace behind. But the quantum world, with its unwavering laws, tells a very different story. One of the most sacred principles of quantum mechanics is that information can never be truly destroyed. It might be scrambled, transformed, or hidden, but it is always conserved. This principle, known as unitarity, is foundational to our understanding of how the quantum universe operates. If you burn a book, the information contained within its pages then form the words. The molecular structure of the paper 20 is not lost. It is encoded in the smoke, the ash, the heat, the very chemical bonds that are broken and reformed. In principle, given enough information about the byproducts, you could theoretically reconstruct the original book. And so, we arrive at one of the most profound and perplexing mysteries in modern physics, the black hole information paradox. On one hand, classical general relativity dictates that information falling into a black hole is utterly destroyed. On the other, quantum mechanics insists that information must always be conserved. These two fundamental pillars of our cosmic understanding stand in direct, uncomfortable opposition, creating a deep, philosophical chasm at the heart of reality. Imagine a single particle encoded with a unique piece of information about its quantum state, gently falling toward a black hole. As it crosses the event horizon, it seems to vanish from our universe, its information seemingly lost forever. This is where the paradox truly deepens, especially when we consider the groundbreaking work of Stephen Hawking. He discovered that black holes are not perfectly black. They slowly evaporate over incredibly vast timescales by emitting a faint glow known as Hawking radiation. This radiation, however, appears to be purely thermal, like the generic hiss of a cosmic oven, carrying no discernible information about what fell into the black hole. It is as if the black hole emits steam, but the steam tells you nothing about the specific recipe of the cake that was baked inside. If the Hawking radiation truly carries no information about the black hole's interior, then where does the information from the swallowed particle go as the black hole slowly dissipates? Does it simply vanish from existence, violating quantum mechanics? Or is there a subtle way the information is encoded, perhaps in the quantum correlations or entanglements of the emitted radiation? A cosmic code that we simply haven't learned to decipher yet. This paradox is not merely an academic puzzle. Its resolution holds the key to understanding the very nature of spacetime, gravity, and the fundamental role of information in the universe. Some theories suggest that information might be encoded on the event horizon itself, like a cosmic hologram, where the two-dimensional surface of the black hole contains all the information about the three-dimensional space within it. Others propose that tiny, subtle quantum connections, perhaps even wormholes, could provide a secret escape route for information, weaving it back into the fabric of the universe in ways we cannot yet grasp. To solve the black hole information paradox would be to achieve a monumental leap in our understanding, potentially unifying general relativity and quantum mechanics into a single, cohesive theory of everything. It is a puzzle that invites you to ponder the ultimate fate of information, the deep connections between space and time, and the profound mystery of what truly constitutes existence. As you drift into a state of deep rest, allow this profound cosmic enigma to gently occupy your thoughts, a silent question whispered across the vastness of the universe. Perhaps this grand tapestry, this vibrant, unfolding reality that we perceive with all our senses, is not as solid as it seems. There is a whisper in the deepest physics, a gentle suggestion that our entire three-dimensional universe, with all its stars and galaxies, all its intricate dance of life and shadow, might in its essence be a projection. Imagine, if you will, the delicate shimmer of a hologram. From one angle, it's a flat, two-dimensional surface, holding an impossible wealth of information. But tilt it just so, and suddenly, a three-dimensional image springs forth, vibrant and solid, appearing to occupy space where there is none. The holographic principle, a bold and beautiful conjecture, posits that the very fabric of our perceived reality might operate on a similar cosmic scale. It suggests that all the information contained within our expansive, three-dimensional universe could be encoded, stored, and imprinted upon a distant, two-dimensional boundary. Picture it, a vast, unseen surface, far, far away, perhaps at the very edge of the cosmos, acting as an infinite canvas. On this canvas, every single detail, every particle, every interaction, every thought, every ripple of energy that ever was or ever will be, is meticulously etched as a flat, delicate pattern. And what we experience, what you touch and feel and breathe and dream within, this immersive volumetric reality, is merely the vivid, unfolding projection of that information. It is a thought that gently untethers the mind from its anchors of solidity. We look out at the boundless night sky, at the nebulae painting cosmic masterpieces, at the galaxies spiraling in slow, majestic dances, and we feel the immense depth of space. Yet, this principle invites us to consider that all this perceived depth, all this profound dimensionality, could be an intricate illusion, a grand performance orchestrated from a flatter, more fundamental stage. The universe, in this view, becomes a vast cosmic cinema, projecting an endlessly detailed, utterly convincing story onto the screen of our awareness. We are not just within the projection, perhaps in a deeper sense. We are also part of the information that 4D creates the projection. This concept gently blurs the lines between what is truly real and what is merely a profound manifestation of underlying data. It suggests that the solidity of the chair beneath you, the warmth of the blanket wrapped around your body, the gentle rise and fall of your chest with each breath, these are all incredibly detailed, richly textured expressions of information that resides on a boundary we cannot yet see, or perhaps cannot yet fully comprehend. It is like living inside a dream that is so exquisitely crafted, so utterly consistent, that it takes on the undeniable quality of reality. And perhaps, like a dream, it is only upon awakening to a deeper truth that the illusory nature of its three-dimensional solidity might reveal itself. This holographic universe whispers of an elegance so profound, a simplicity so fundamental that it can generate unimaginable complexity. From a seemingly flat canvas, dimensions unfurl, stars ignite, and consciousness blossoms. It is a concept that doesn't diminish reality, but rather expands its potential, painting it as an artistic masterpiece of cosmic proportions, an infinitely detailed projection woven from the unseen threads of information. And as you drift, imagine that every quiet thought, every gentle sensation, every silent beat of your heart is an intricate detail being projected, moment by tender moment, onto the grand holographic canvas of existence. Our journey through the quantum realm, from its pixelated foundations to these breathtaking projections, constantly, gently challenges the very framework of what we thought we knew about reality. It is a journey that, in its quiet revelations, inevitably leads us to confront the boundaries of our own understanding. The world we inhabit, the world we perceive through our senses, is a macro world. It operates on scales where objects are solid, where positions are certain, where causes lead to predictable effects. Our brains, our logic, our very language have evolved to navigate and make sense of this tangible classical reality. We build models, we form expectations, and we draw conclusions based on these familiar comforting rules. But the quantum realm, with its shimmering uncertainties, its probabilistic dances, and its profound observer effects, feels alien to these deeply ingrained intuitions. It is a world where things exist as possibilities until observed, where particles can tunnel through impenetrable barriers, where two distant entities are inexplicably linked. These truths do not align with our everyday experience, and often they seem to defy the very logic we've painstakingly constructed over millennia. And so, a quiet question begins to emerge. A gentle murmur beneath the surface of our awareness is our human perception, our finite capacity for reason, truly equipped to fully grasp the ultimate, unvarnished truth of the universe? Or is there a fundamental wall, a veil of understanding that we, as beings rooted in the macro world, are destined to encounter? This isn't a limitation of our intelligence, but perhaps a feature of our existence. Our minds are magnificent instruments, capable of intricate thought and profound insight, but they are also shaped by the environment in which they evolved. We are programmed, in a sense, to see and interact with a reality that presents itself as stable and continuous. To fully comprehend the quantum layer, we are asked to shed these ingrained habits, to embrace a fluidity and ambiguity that our classical minds naturally resist. It is like trying to understand the nuances of a complex symphony by only listening to individual notes, or trying to grasp the vastness of the ocean by only looking at a single wave. We perceive fragments, patterns, and echoes, but the grand unified truth might remain just beyond our immediate grasp. Perhaps the ultimate nature of reality, in its deepest, most quantum-infused form, is destined to forever transcend the logical frameworks we construct. Perhaps it is so fundamentally different, so exquisitely subtle, that any attempt to fully package it within our existing concepts will always fall short. This thought, rather than being unsettling, can be profoundly liberating. It invites a gentle humility, a quiet acceptance that there are wonders so immense, so delicately woven, that they may forever exist in a realm just beyond our complete intellectual capture. It suggests that the universe, in its boundless mystery, might always hold a part of itself in reserve, a secret garden accessible only through quiet contemplation, not through absolute definition. So, as you rest, let your mind gently release the need for absolute certainty, for a fully defined, perfectly logical map of reality. Because in the quantum realm, the most profound truth is perhaps the one that continually expands our sense of wonder. It tells us with every strange revelation that reality is infinitely stranger, infinitely deeper, and shimmering with far more possibilities than our boldest imaginations could ever conjure. It is an ongoing invitation, a soft, encouraging whisper from the cosmos, urging us to let go of our rigid grip on what we think we know. This universe in its quantum essence is not a fixed, predictable machine, but a living, breathing symphony of potential. It is a place where possibility dances with actuality, where the seen emerges from the unseen, and where the most fundamental laws are written in the language of probability and interconnectedness. Embracing this means gently releasing our attachment to absolute answers, to the idea that every mystery can or must be fully unraveled and neatly filed away. Instead, we are encouraged to simply be present with the wonder, to marvel at the sheer, improbable artistry of existence. The miracles are not just in the how of things, but in the that of things. That anything exists at all, that matter coalesces from fields, that light and shadow play their eternal dance, that consciousness can arise to ponder these very mysteries. Soothe, these are the true wonders, and the quantum realm in its elegant, bewildering way only amplifies this sense of profound awe. It tells us that we are part of something unimaginably vast and intricate, a grand design that defies simplistic explanation. In this embrace of the unknown, in this quiet reverence for the unceasing surprises of the universe, our minds can truly find a different kind of peace. Not the peace of understanding everything, but the peace of accepting the magnificent, boundless mystery. It is a peace that comes from recognizing that we are small yet intimately connected to everything, woven into the very fabric of this quantum tapestry. It is the peace of knowing that beneath the surface of our everyday world lies an endless ocean of potential, a realm of constant creation and recreation. And as you drift into sleep, remember that you too are a part of this unfolding miracle, a gentle ripple in the grand, wondrous quantum sea.